Welcome to the Explainer. Today, we're unpacking something absolutely fundamental, the principles of motion, distance, and speed. We navigate the physical world literally every single day, walking, driving around, but how often do we actually stop to analyze the physics of that journey? We're going to build our understanding right from the ground up, using our source material to reveal the really elegant structured system that's hiding behind our daily movements.
So consider this fundamental question. What is the true measure of our movement? When you go from point A to point B, how do we scientifically define that journey through space? Is it just the literal steps you took, or is it strictly where you ended up? Well, we are going to look at the anatomy of a journey to figure this all out.
Okay, let's dive right into this. Section 1, the path covered. Before we get into any complex vectors, we have to talk about simply moving. Distance is defined as the total path covered by an object during motion. The absolutely operative word here is total. This is the baseline for our journey. Literally every single step counts. If you wander around a room in a giant circle, distance meticulously tallies up every single inch of that winding path. Now, distance relies on three crucial attributes. First up, it's what we call a scalar quantity, and that simply means it possesses magnitude only. Think of it as a pure amount, like 10, 50, or 100, without any regard for direction whatsoever. And finally, its international standard unit of measurement is the meter. So distance is really just a number of meters showing the total path you took. Which brings us to our first real plot twist. Section 2, distance versus displacement. We know how much path we've covered, but what if the winding path doesn't actually matter? Displacement is the shortest distance between the initial and final position of an object. Highlighting that exact phrase, shortest distance, is the real game changer here. Displacement completely ignores all your wandering around and just draws a perfectly straight line from where you started directly to where you stopped. Now, what's really interesting here is how this fundamentally differs from distance. Displacement is a vector quantity because it has both magnitude and direction. It is no longer just an amount, it's an amount pointing somewhere specific. You aren't just 10 meters away, you are 10 meters north. That addition of direction is exactly what transforms this from a basic scalar quantity into a precise vector quantity. Putting them head-to-head really highlights a stark dichotomy. Distance is a scalar, magnitude only, just moving. Displacement is a vector, magnitude plus direction, targeted movement. It's basically the difference between asking your fitness tracker, hey, how many steps did I take today, versus asking a compass, how far am I from my starting point right now, and in exactly what direction. Let's lock this concept in with a specific scenario, almost like a puzzle to solve. Step 1, a boy walks 4 meters east. Step 2, he turns around and walks 3 meters west. Keep that mental image really clear in your head. 4 steps forward, 3 steps back. Okay, so if we want to find the distance, we look at the total path covered. It's just simple addition. 4 plus 3 equals 7 meters. Every single step counts, totally regardless of the direction he was walking. The total physical effort expended was 7 meters worth of walking. But what is his displacement? Well, because he walked 4 meters east and then turned back 3 meters west, he almost completely undid his entire journey. His final position is separated from his initial position by exactly 1 meter east. So a distance of 7 meters, but a displacement of just 1 meter east. It perfectly illustrates how vectors operate in the real world. Let's move on and see how this all builds together. Section 3, calculating our speed. We have completely mastered space, but now we have to introduce the final element of our journey, and that's time. Speed tells us how fast an object moves. It's the ultimate measure of quickness, basically the scientific answer to the age-old road trip question, are we there yet? Formally, speed is the distance traveled per unit time. Notice the structure of that. It takes our very first concept, distance, the total path covered, and restricts it with a time limit, creating a neat little ratio. Let's set up a final real-world example to really test this formula out. Think of a road trip. A car travels a distance of 100 kilometers, and the entire journey takes 2 hours. So we have our total path, and we have our unit of time. To do the math, we take that total distance of 100 kilometers and simply divide it by the 2 hours of time it took to actually cover it, which gives us our final result, 50 kilometers per hour.
By taking two basic variables, distance and time, we easily calculate a really precise metric for the object's rate of motion. It's incredibly satisfying how clean these physics equations can actually be.
As we wrap up this explainer, I really want to leave you with a final thought. The next time you move, ask yourself, are you just covering distance or are you actually displacing? Every single time you commute or just pace around a room, you are actively participating in this elegant scientific framework. Thank you so much for joining me to explore these principles today, and I genuinely challenge you to apply this new perspective to your very next journey.